The most successful Ethereum use case that has caught the attention of the general public is the non-fungible token and its variations. The NFT is a representation of a material or digital object in the decentralized space. It has both an on-chain and an off-chain part. The off-chain part, the actual object and its metadata, is stored on a hopefully decentralized storage system and is reduced to a unique resource identifier. This unique resource identifier is stored on-chain along with information about ownership and what operators are allowed to transfer the NFT on the owner's behalf. We have implemented an NFT contract with the Ethereum Data Service technology, an EDS-based NFT. One of the most known and used interface for NFTs is EIP 721, and our EDS-based NFT follows this EIP 721 standard. One of the safest, well-known, and efficient implementations of this standard in the Solidity language is the OpenZeppelin implementation, and this is what we are using today as reference for comparing gas costs. These are the gas costs for the Solidity implementation, and these are the gas costs for the EDS-based NFT contract. From the start, we can see that the EDS-based implementation is more expensive for transfers and approvals. We have an additional 24,864 gas units for transfers, 17,322 additional gas units for setting an operator, and 2,051 additional gas units for setting an approved address. This is expected because EDS has some internal costs in addition to the pure NFT costs. Some of these costs will eventually be written off, but this will be covered in another video. Our present goal was to have comparable gas costs with the reference implementation, even if slightly increased. So, deployment gas cost is over 1.8 million for the EDS-based NFT and over 1.6 million for the OpenZeppelin Solidity implementation. The EDS-based contract also has an init function which costs around 900,000 gas units. Now, gas costs for operations. Gas costs are different per operation if the addresses have been registered in the system before or not. For example, minting your first NFT is more costly than minting a second NFT for your address. Transferring an NFT to an address that does not exist in the system yet is more costly than transferring to an existing user, and so on. So we will look now only at the minimal costs, when users are already registered. Minting now costs less on the EDS NFT. 90,322 gas units compared to 149,935, so 60% of the cost. Base transfers cost 65,315 compared to 40,451 on the Solidity implementation, so 161% of the reference cost. Setting an operator costs 63,569 gas units compared to 46,247, which is 137% gas cost. Setting an approved address costs 50,828 on the EDS-based NFT and 48,777 gas units on the Solidity implementation, so 104%. And the EDS-based NFT has a slightly larger bytecode than the Solidity implementation. Given the slightly higher gas costs, why use EDS for implementing NFTs? With EDS, you can decouple data from behavior and increase upgradability. And many contracts can collaborate with the same EDS-based contract. And if you saw our Ethereum deep object pattern videos, you understand the inter-contract interactions that can be achieved. Data is gas efficient, packed efficiently collision-free, easier to analyze by block explorers, and ready for optimizing gas when Verkle trees will be used for persistence. The way we pack data is an advantage for data mirroring on other chains and data bridging. As for off-chain, because we have mechanisms to keep track of data changes, EDS is compatible and ready for Layer 2 optimistic rollups. And it is easier to simulate the on-chain data off-chain using a classical database engine. State debugging is easier as you get to see the entire storage layout in a structured way. For off-chain use for applications, data can be hydrated from various sources including on-chain deep objects. And the EDS also allows for full text indexing off-chain and search right in the EVM. This is a first EDS-based NFT implementation. It has helped us discover useful patterns for how to use the EDS system. And soon we will have more demos showing the advantages of using EDS for creating truly decentralized objects.